Hello, YouTube. This is Umills03. In the previous two lessons, we took a look at two different ways of iterating through code. That essentially means repeating and printing out a lot of code without necessarily needing to write a lot of lines of code. And we talked about two different ways to do it. So we essentially have a while loop available to us and a for loop available to us. And so if we go ahead and open the Hello World class, I think I still have an example up from the previous video. Remember, we were taking a look at going back and forth between the while loop and the for loop implementations. If we have a while loop, things are a little bit disconnected, right? So we sort of have an initialization of a counting variable maybe before the loop even starts. And then for the method header, we just have while and then a particular Boolean that we want to check at the top of each iteration. And then inside of the body, we're just going to have the code that we want to repeat each time. But it should be some concrete action, like printing system.out.println of p would be like a concrete thing that you're going to do every time you run through the loop. But what you're also going to do with each iteration through the loop is update the value of p in such a way that eventually this Boolean p less than 5 is no longer going to be true. And that's what basically the technique that you would use to prevent an infinite loop, is that you certainly want that Boolean to be true the first time you check it, right? 0 is less than 5, obviously. But eventually, if you keep incrementing p, we'll be able to exit out of the loop. Eventually, we'll be able to stop loop execution, right? Because you don't want to have a loop that runs infinitely many times. It turns out that there's actually another way to control loop behavior, and there's actually another way to terminate a loop or control its behavior beyond just this primary Boolean that we're taking a look at, right? So we've had a traditional while loop and a traditional for loop. And so what we just have what we have this Boolean expression for is to just regulate the number of times that we run through the loop, right? So the Boolean starts true and the loop runs over and over and over again. And then suddenly something happens in the execution of the loop body where the p or the power is getting updated, and then eventually the Boolean is no longer true. But what if you had a Boolean that was always going to be true and you didn't have really any other way of breaking out of the loop? And the answer to that question is to say that in this lesson, we're going to talk about the break and the continue keywords. These are keywords that you can write to basically, what we can do. Let's clarify what the behavior of these two keywords is, okay? Because we've already seen the word break before. If you recall in lesson 11, we were talking about the switch statement. And we said basically the way that a switch statement works is that you say switch of variable or expression. So you say in parentheses, you basically have an int or some integer transformation of an int, right? Like if x is an int, you could say switch of x plus 2 or switch of x times 5 or something like that. But what you would do is you would line up that variable or expression against possible case values. And we said that once one of the case values is true, you're going to run that case and all cases below it unless you hit a break. And so what we're going to do is we're going to see another use of the break and continue keywords in this particular application. We haven't seen continue yet, but we're going to see break again. So what break does is it ends all operation of the loop immediately. So stops current iteration and does not check Boolean for future iterations, right? Because we said typically with a while loop or a for loop, you would just go ahead and run the loop body, and then you just go ahead and check the Boolean again at the top to see if you're going to iterate again. But with break, we say, no, you're done. Not only are you done with the current iteration, but don't even pass go, don't collect $200. Don't go back up to the top and check that Boolean again. We are literally stopping all loop activity. Continue is different. So continue ends the current iteration of the loop, but basically redirects the program to check the Boolean to basically for the next iteration. So what continue does is basically it says, stop what you're doing in this particular iteration, but if you want to continue iterating in the sense of looking to see if there's another iteration that might happen when you look at the Boolean, then that's okay. So we're going to see some examples of that in the next 15 or 16 minutes. But what we're going to do is we see a for loop here and a while loop here. And what we're going to do is we're going to change this Boolean so that the Boolean that we will put in between these two semicolons would always be true. And there's different ways that you could do that, right? So if you think about a power variable that starts at 0 and is just going to go up by 2 every time, there's a lot of ways you could guarantee that a particular Boolean is going to be true. One of them is to write true there. And now this loop would literally run forever and ever and ever and ever and ever. It's just going to keep incrementing power by 2, right? And it runs as long as the sky is blue, right? As long as true is true. And so then this would go ahead and print power. And in fact, if you try printing something after this loop, Java already recognizes this as an infinite loop. So if you try printing the result of 15 times 5, it throws an error with the entire line and says, guess what, buddy? I'm never going to get here because you have me printing power until the day I die. The solution to this is to go ahead and have a Boolean that you're going to check inside of the code. So you're going to check a Boolean every time you're inside of a particular iteration. So the Boolean is going to be in the loop body, right? So true is always true. So essentially you're always going to be starting the loop body so you're always going to run these iterations, but inside of each of the iterations, there's going to be an if statement. And basically, if that Boolean is met, you're going to break out of the loop. And so what's the Boolean? The Boolean is if you get to a power value that's too high. So we were doing 5 in the previous video. Let's make it a little bit higher just so that we can demonstrate what's going on here. We're going up by 2 each time. So what you're going to do is you're going to say if power gets to 15. So if power is greater than or equal to 15, you're going to break out of the loop. So what this does is it's going to basically run this loop an infinite number of times. But what it's going to do an infinite number of times is check this Boolean, right? Because this is part of the loop. It's going to iterate the code over and over again. It's going to check this Boolean every time. And what power does is it's getting bigger and bigger. As you can see, it's getting 2 points bigger each time we iterate through the loop. So eventually this Boolean is going to become true, right? You're going to go 0, 2, 4, 6, 8, 10, 12, 14, 16. So by the time power gets to 16, you're going to break out of this loop, and then you're not going to print that value of P. You would not print 16, because when you break, that doesn't mean end the current iteration and then you're done. It means you're done literally this instant. Stop what you're doing. Okay, you're literally done with this loop. Literally completely done with the loop. So now what we can do is we can go ahead and try to run the main method, and hopefully you can sort of predict the output that we're going to get. Is we're going to be printing basically multiples of 2 from 0 up to 14, right? Because then 14 is going to jump to 16, and then 16 satisfies this Boolean, unfortunately, which means that we have to break out of the loop, right? So then if we go ahead and compile it and run it, this is just another way that we can regulate loop behavior. And indeed, we only get 0 through 14, right? And you could go ahead and what if you could do something else? What if you said power is greater than -1, right? So if you start at power equals 0 and you go up by 2 every time, literally power is always going to be greater than -1 if all it's doing is getting larger and larger. And so basically with this Boolean, this is an example of a Boolean where you would need some other way to break out of the for loop, because the for loop itself is not going to break. It's not going to break out of itself with this kind of an expression, right? You have to just see whether or not this Boolean could ever be false. And if this Boolean could never be false, that's a problem. And the way that you solve it is by having this break statement. We said that a break statement basically ends all operation of the loop. So what we could have done here, but we don't need to do, is we could have said if the power is greater than or equal to 15, break, otherwise print power. But here the else architecture makes no difference, because what happens is if the power is greater than or equal to 15, it runs break, and then it's not like an ordinary line of code here, right? Because in an ordinary line of code, you could just run an if statement, right? You could say if 3 + 3 is 6, then print something, right? And then if it goes ahead and prints that, then it can keep running the code, right? It would just print that, and then it would look below the if statement. But if you're talking about a break, that means you're not going to look below the if statement. So in a way, it sort of basically functions the same way, regardless of whether you have the else logic here. Is if you break, you're not doing this code, but if you don't break, then you are doing this code. So hopefully you understand how that works. So that's the break statement, and you could do the same sort of thing with a while loop, right? So you could go ahead and say, what we're going to do is we're going to say string W equals word, okay? And what if I want to print the uppercase version of this word? So I want to print the same example as we did previously. So what we're going to do is we want to print the uppercase letters of this word, but each uppercase letter is going to go on a different line. But what I'm going to do is I'm going to make a while loop, and I'm not going to know where to stop. So what I'm going to do is I'm going to say int p equals 0, and then I'm going to say while p is, you know, you could say, well, P is less than W dot length plus 1. Okay, so the problem is that if you don't cut off until W dot length plus 1, eventually P is going to get to W dot length. Okay, so P would be equal to 7, and then it's going to try to form a substring. You're going to try to grab the character at index position 7, and that would throw what's called an exception. It would throw an error. So what you would need to do to actually prevent it from getting to W dot length is you would need to have an even more constraining Boolean where you say, as you run through this loop, you need to check this Boolean within the body of the loop. And that Boolean would say, if P gets to W dot length, break out. So now you would say, if P equals W dot length, then you could break out, because this is going to be the one time, this is going to be the one value of P where you still satisfy this Boolean. But then if you call the substring method on this W string object starting at index position P, you would have an issue. Starting at W dot length, you would have an issue, right? So here you'd have to break out. So basically breaks out a little earlier than the loop's main Boolean would have, because P equals 7 is not a valid index position. Okay, so you could say if P is equal to W dot length break, and then you could say otherwise, or you don't even need to say else. What you could do is you could say system.out.println, and then you would basically grab the substring. You would just grab a substring of length 1. So I think we did this in the for loop video, but you would do w.substring of P and P plus 1, and then you could just go ahead and convert it to uppercase. And so hopefully this is clear to you what's going on here. And so now if we go ahead and compile and run it, and we still get an infinite loop. So what did we do wrong? This is another example of where we forgot to increment P. And so that's what we would have to do here. So we just need to remember to increment P. This is another example of where the while loop is failing me, right? Because in a for loop, it's easier to remember the incrementing of the P, right? So now what we have to do is just after we print the current character at index position P, we just need to increment P so that eventually we can get to the end of the word. So now if we go ahead and run it, then it can print Phoenix, right? And this Boolean could have been as whatever you wanted it to. What if you weren't going to stop until P was less than W dot length plus 100? It's the break statement that really saves you here, right? It's the break statement that really saves you here. And so you still just get Phoenix. What if what if your main Boolean is more constricting? So what if P is only allowed to go to W dot length minus 3? Well, that means that in the execution of your code, your break Boolean is never true, okay? And then it would be your main loop Boolean that cuts you off. So here, we're not even gonna get a full Phoenix. You would just get PHOE, because we said that P is only allowed to be less than W dot length minus 3, right? So once P gets to 4, it says, uh-oh, I'm not less than W dot length minus 3 anymore, and that's why you don't get that N. We also need to talk about a word called continue. So what continue does is it ends the current iteration of the loop, but it redirects the program to check for the Boolean, check the Boolean in the next iteration. It says, I want you to stop the current iteration, but if the Boolean remains true, then you can do the next iteration, maybe, unless you run into another continue, and then you have to stop that iteration and try the next one, right? So continue stops the current iteration, says try the loop again at the top. If the Boolean is still true, break says you are literally done with this loop. I don't care where you're at in it. Don't do anything else with it for the rest of this program. So what we're going to do is we're going to come up with a method that will print only the even integers from 0 to 20. And we can think about a couple of different ways to do that. Let's do it with a for loop. So one of the ways that you could print the even numbers from 0 to 20 is you could say, for example, for an s equals 0, s is less than or equal to 20, s plus equals 2, and you could just increment by 2 each time. You could say system.out.println of s. And hopefully this code's very clear to you what this is going to be doing. So if we go ahead and compile it, and then we run it, and we get 0 to 20 like that. What we could also do is we could just increment s by 1 each time. So we could go ahead and look at every value of s. But if s mod 2, if the remainder when we divide s by 2 is anything other than 0, what we're going to do is continue, which means that we're going to skip any potential code where we could potentially be printing a value of s that we don't want to print. So what we're going to do is we're going to change this back to a 1. So typically this would be printing all the values of s from 0 to 20. right? But we're going to come up with a different way to print the even numbers, but by using plus equals 1 here. So what you're going to do is you're going to say if s mod 2 is not equal to 0, right? If the remainder when I divide s by 2 is not 0, so you'd really only be talking about 0 or 1, right? So basically, if you're saying if I do not have an even number, then what you're going to do is you would say continue. And this is another example of where the else architecture is going to be optional. Because if this Boolean is true, if s mod 2 is not 0, it's going to continue, which means that you would be done with this the current iteration of the for loop. So it wouldn't make a difference whether or not you said else here, right? Because if it goes to continue, then it's just going to increment s by 1 and check this Boolean again. It's just going to go up to the top, incrementing s by 1 and checking to see if s is still less than or equal to 20. So the else architecture, like I'm saying, is optional. So you could just say system.out.println of s. And so this Boolean would prevent any values of s that satisfy that Boolean from being printed, because we're just going to end the current iteration before we have the chance to print s. So now if you go ahead and compile it, you should see that we only get the even numbers. And that's an example of using continue. And so hopefully that's clear to you. That's usually a pretty standard example of using continue. I mean, you could use it to count elements or something, right? So you could do it. We could do an example with a while loop or something, where we could say something like, you could say int y equals 0, and then you could say, while y is less than 45, and then basically you could count the multiples of 10 or something, right? So you could say something like, you could say if y mod 10 is not equal to 0, then you could continue, right? So basically what we could do is we could come up with, so number of multiples of 10. I'm going to have a really obnoxiously long variable name, right? But you could count the number of multiples of 10 from 0 up to some point, right? And so you would say, if y mod 10 is not equal to 0, just continue, don't even bother, right? But then you could say otherwise, right? We said the else architecture really makes no difference here, but what you could do is you could say otherwise number of multiples of 10 plus equals 1, and then you would just go ahead and return that value, and so it would just give you that value, right? So that's essentially what you have going on here. And then you would just go ahead and say, and then you could just go ahead and print that, right? So you could say int upper limit. You can make variables for everything, right? So you could say upper limit here, and then you could say number of multiples of 10 between 0 and then you concatenate with the upper limit, and then you would just return that result. So you could have a colon here. We're just concatenating strings and ints together. And so now you would just have the colon, and then you could say number of multiples of 10. So this is not the prettiest example, but I just wanted to sort of show you essentially what this code would be doing, right? Because the only time that it would not continue is if y mod 10 is equal to 0, but by not continuing, that actually means it sort of does continue, right? It continues the current iteration. So the only time you increment this variable is when y mod 10 is 0, and that happens for 0, 10, 20, 30, and 40. So if you set an upper limit of 45, we should be expecting to see 5 on the console output. And again, we have an issue with our while loop where I'm being an idiot and forgetting to change the value of y. So now what we're going to do is go ahead and do some problem solving again. And you could just say something like y plus plus if you just want to increment it by 1 each time. And we want to check every value of y. So what we would do is we would go ahead and run that again, and there's still going to be an issue, right? So what you would have to do here is you would have to actually go ahead and increment y before you continue, right? Because if you get to a remainder that's not equal to 0, you would have to you're going to have to go on to the next value. Otherwise, the value of y would not update, and you would just continue, right? But then you would never be able to increment the value of y down here. So that would be an issue. Okay, so hopefully you can understand how that's working out. And then what we're going to do here is we're just going to go ahead and compile it, and hopefully that will run this time. So we need to reset the Java virtual machine. But I want to show you that the continue keyword is doing what it's supposed to be doing. So it says number of multiples of 10 between 0 and 45 is 5, and that's what we expected. So hopefully you understand that break ends all operation of a loop, continues simply ends the current iteration, and allows the Boolean at the top to be checked again. So from UMILS03, thanks for watching, and please subscribe.